Good morning, everybody. First, I would like to thank the organizers for giving me this opportunity to present our work. And I also would like to acknowledge my colleagues, co-authors at the University of Minnesota, Washington University in St. Louis, and Georgia Tech. And I'll be sharing with you today results from St. Louis Air Quality Regional Study SLAQRS campaign conducted in the summer of 2013. And we have a picture of our site here. It's located close to downtown St. Louis, and you can see the major highways here nearby. So why St. Louis? I have an isoprene emission factor for southern US here to show the contrast between north and south in terms of isoprene emission. And St. Louis is located here, right at the border between these two different regimes. And also it lies at the northeastern edge of Ozarks, which is known for its high isoprene emission and often called as isoprene volcano. And the windrows during our study is shown here. The prevailing wind was coming from south and also from northeast. So it gave us an opportunity to study how the interaction between biogenic and anthropogenic emissions affect the air quality in this region. VOCs were measured using proton transfer reaction mass spectrometry technique, and I have pictures of our instrument and the inlet system here. We used hydronium ion as ion source, and the time resolution was about 2 to 3 minutes, and we sampled about 5 meters above ground. So let's look at some time series. If you look at the isoprene concentrations, it showed really large variation, ranging from less than a ppb to as high as 8 ppb here. And the main oxidation product, MEK and methaclone, also showed enhancements during this high isoprene events. And in contrast, the anthropogenic species behaved quite differently, as you can see here. And here, these green lines show the periods when we had southwesterly winds. And these southwesterly winds correlated very well with this high isoprene events, indicating that during this period, our site was impacted by these biogenic plumes from Ozarks. And again, in contrast, the benzene didn't really show any correlation with this wind. And if we look at this high isoprene events, in fact, the highest concentrations were observed at night. So in this case, these red lines show the midnight. And so we could see as high as 6 to 8 ppb of isoprene close to midnight. These plots show the concentrations as a function of wind direction and wind speed. So the highest ozone was observed during this southwesterly winds here, and isoprene, MEK, and methaclone, also particulate eye epochs, which is a unique tracer for isoprene oxidation in low NOx environment, were observed and enhanced during southwesterly winds. And interestingly, the total PM less than 1 micron was also enhanced during westerly and southerly winds here. And if you look at anthropogenic species, benzene, obviously they were present regardless the wind direction here. But again, the highest concentration in this case is associated with northeasterly winds. So here I am comparing periods when we had westerly winds and also other wind directions in red. So southwesterly winds are shown in green. And southwesterly winds are usually characterized by higher temperature and higher humidity here. And the isoprene, higher isoprene, and the methaclin. But the northerly winds have higher NOx, higher NO. But even during southwesterly winds, we still get the NO concentrations higher than 1 ppb, suggesting that since it's an urban area, this is quite high NOx environment. And if you look at the diurnal profile of isoprene and the methacrylin, they are very unique. You don't see profile like this every day. So we see low concentrations of this species during the day, as they are very reactive and are depleted during the daytime transport. But in the late afternoon, the photochemistry slows down, but the isoprene emissions are still occurring. So we start detecting the species later in the afternoon, and they persist throughout the night here. And if we look at the OX, which is sum of ozone and NO2, the southwesterly wind has definitely slightly higher OX in average. So there's about 10 ppb difference there. And also I would like to point out here that the OX, this green one shown here, peaks earlier, so they have different profile. And here I have some example nighttime profiles of isoprene, MEK, and methacrylin. So some nights we had low isoprene, they decreased, the concentrations decreased, sometimes at the same rate, and sometimes isoprene decayed faster than MEK and methacrylin, but sometimes we had the very high levels of this species, and the concentrations, instead of decreasing, they persisted and built up until sunrise here. So for the nights when we had faster isoprene decay, here the isoprene is shown in log scale. For these nights, the NO levels were comparatively low for this environment. So this particular night, we had NO less than a ppb, and the loss rate of isoprene, shown here in blue line, was dominated by the loss rate due to isoprene reaction with the NO3 here. And so if you look at estimate the lifetime of isoprene, based on this loss rate, we get about 4 hours, which is consistent with the lifetime 3 to 4 hours estimated from the measured isoprene profile. But for the nights when we observed the buildup of isoprene, the NO levels were high. So this particular night we had NO about 3 ppb. And high abundance of NO titrates the nighttime radicals NO3 and ozone, so the loss rate of isoprene was very low, which corresponded to estimated lifetime in hours, I mean tens of hours, so 30 to 50 hours. So really the key was here, the high NO titrating the nighttime radical. Here. So what happens when sun comes out? As this plot shows here, the sunrise is at around 5 a.m. in St. Louis local time. And so here this dashed blue lines show the average of the whole campaign, and the red lines show this particular day when we had a high isoprene, MEK, and methacrylin from previous night. And the water vapor concentration showed a rapid decrease around 8 a.m., indicating growth of PBL. And when sun comes out, we see this rapid decrease in isoprene due to photochemistry. And MEK and methacrylin during this time showed slower decay, and sometimes it increased here, consistent with the production and also chemical loss here, and we see this small peak around 8 o'clock, 8 o'clock here, which we attribute to probably entrainment from residual layer, and also local isoprene chemistry contributing to this. But so if we compare, if we look at the OX level here, OX is definitely higher than average of the campaign. So there's about 30 ppb enhancement in OX. Also, it peaks earlier, so it's peaking before noon here. And we looked at different days in terms of isoprene concentration in the morning and also ozone levels. And this plot shows days with high isoprene in the morning from previous night. Isoprene concentrations higher than 2 ppb, to be precise, in black lines, and the red lines show the average of the campaign. And during these days with the high morning isoprene, we had the ozone or OX profile has, all of them have this early peak before noon, and the shape is just very different than the average of the campaign. And to contrast that, we have few days here when, but there are definitely more days with low isoprene, but if we have isoprene less than a ppb in the morning at sunrise, the corresponding OX profile has a shape similar to the average of the campaign. So isoprene from previous day, if present, can lead to very efficient photochemistry in the morning. So as a summary, we observed extremely high levels of isoprene and its oxidation products under southerly winds, the highest amounts occurring at night. And also the loss, chemical loss of isoprene in this environment was very low, which led to the buildup of isoprene. And this can be attributed to the low NO3 abundance in urban nocturnal boundary layer. And if isoprene is present, present in the morning, we saw very efficient photochemical production of ozone the next day. All right. So here's my acknowledgement, and thank you for your attention, and I'd be happy to take any questions you have.
Time for some questions? I'll start with one. People have thought that isoprene can be removed at night by deposition. Did you see any evidence of that?
Yes, it could be the dilution too, because some nights we've seen decrease in isoprene and also in imiquimethicillin too.